Good morning. Today we are going to see how to find forces in the truss members by section method. Now we are going to find out forces in member U2L2, U1U2, U1L2 and L2L3. And truss we have shown in this fashion. 6 panels 2 meter each means we have these 6 panels 2 meter, 2 meter. So 3 on left side of center and 3 on right side of center. Then we have forces on this. We have intermediate panel 0.4 kilonewton and panel 0.2 kilonewton. So we have, this will be upper chord. So we have mentioned by U, and lower chord we have mentioned by L. Now we will consider first section which will cut these three members. So that is your choice. I have considered like this. You can consider vertical section and which will cut these three members. So I have considered these three members. So now to cut these three members, we have to go section like this. So generally minimum number of members should be cut by this section, and force, the member in which force is required should be cut by this section. So now we will go with this. So we have this section, and therefore we will have two parts below this section, above this section, and both parts are satisfying equilibrium condition Fx0, Fy0, moment 0. So we can apply this condition for both part, left part and our lower part and upper part. Now upper part is larger when we have number of forces and members. So I will consider lower part. So let us consider lower part. So whenever we will go with this, so we have this as 2 meters, we have this as 2 meters. We have to find reactions for this. If we will see this total load, so we have total load that is 24. So 4, 8, 12, 8, 16, 20 and 24. So half of load will be shared by both reaction. So we have to always first calculate reaction and then cut this section and consider the part in which we have lesser loads and members. So now we will consider this. Now keep in mind the members which are not cut by this section. So these are U0, U1, U0, L1, L1, L2, U1, L2 will not take part in your equilibrium equations. So the members which are cut by this section. So we have F U1, U2, we have F L2, U2, and we have F L2, L3 will take part in equilibrium equations. Now we will first find this distance y. So we have angle, actually this is given in the problem itself. So this is given as 30 degrees. So if not given in the examination, you can assume it, and always preferable 30 degrees. So we have y by 2, and from this we will get value of y 1.15 meters. Now we will solve this problem. So now let us assume always tension in the members. Now first we have to see is there any joint through which two members will pass. So if two members will pass, unknown will be 1, and we can take moment about the joint through which two members are passing. Then automatically we will get force in the third member. Now we have one joint through which these F U1, U2 and F L2, L3 passes. So you can go back. So you will see these both are passing through U0. And therefore I will take moment about U0 equal to 0. Now force U2, U1, F U1, U2, 0. F L2, L3, 0. And the members, other members are not cut by this section. So we do not have a moment due to this. Now we have moment due to this reaction 12, but as passes through U0, 0, 2 kilonewton also 0. So we have due to 4 kilonewton clockwise. So we have 4 into 2. And then due to U2, L2, U2 or U2, L2, anti-clockwise. So minus FL2, U2 into 4 equal to 0. Therefore, FL2, U2 equal to 4 kilonewton. And that is tensile as value is positive. Now generally first letter will be whichever joint you are going to see over here. So for this, we have L2, U2, force is same, U2, L2 or L2, L2, both are tensile. And for U1, we are going to write down U1, U2 because we have joint U1. And for L2, L3, we have L2, L3 because we have L2 as joint. So we have now force in this member 2 kilonewton. Now we have to find force in member L2, L3, U1, U2. Now if you will see, then we have only one unknown in vertical direction because now we know this. This is in horizontal direction. So we have only component of this in vertical direction which is unknown. So now we have two components of this. So I will show two components. So we have this as F U1, U2 cos 30. And the second component we have that is vertical, which is F U1, U2 sin 30. And then unknown is only F U1, U2 sin 30. And therefore, we can now use summation Fy0. And then we have 12 kilonewton upward and 2 kilonewton downward. So 12 minus 2. Now this 4 downward. So we have minus 4. This U1, U2 sin 30 upward. So plus F U1, U2 sin 30. And this 2 sin 30. And this 2 also upward. So we have plus 2. And that is equal to 0. And from this we will get F U1, U2 sin 30. And that is equal to, this 2 gets cancelled. And 12 minus 4, we have minus 8. And from this we will get F U1, U2, that is equal to minus 8 by sin 30. And this will be minus 16 kilonewton. And then we can have F U1, U2, that is equal to 16 kilonewton. And that is compression. So we have assumed direction that is tensile. So this is wrong. And we have that will be compression. So whatever component we have shown now that are wrong. So I will just rub this component because these are now not in this direction. For next member, we require this. So we have this, or you can keep and then you can find accordingly. That is your choice. But I prefer always consider correct direction and then solve the problem is always preferable. Now you can see, if you will see carefully, then we have unknown only in x direction and that is Fu2L3. Now we have two components of this. We have one component which will be horizontal and that will be now this U1, U2, we have 16 kilonewton. So we have this as 16 cos 30. So this angle is now 30 degrees. So we have vertical which is downward now. That is 16 sin 30. But we are interested only with x because we have L2, L3 in x direction. So I can write summation fx equal to 0. And then we are going to get minus 16 cos 30 plus FL2 L3 and that is equal to 0. And from this we will get FL2 L3 and that is equal to 13.86 as value is positive. So we have this as tensile. So now only one member that is remained, which we have to find out U1 L2, and therefore now we will take vertical section and then we will remove right part. So we have only left part and then we are going to find out force in U1, U2. So now already we know force in this member is 16 kilonewton. Assume this as tensile F L1, L2. And again this also tensile which is F U1, L2. Now this distance already we have calculated. If we will go back, we have this as 1.15 meter. This is 2 meters. Now we are interested to find in this. So we have to see, are these two members passing through same joint S? These are passing through U node. So I will take moment about U node equal to 0. Now this 16 kilonewton F L1 L2 passes through this. So we have to take now component of this. So we have one component is this and another component we have like. And from this, we can find by taking moment about U not 0. But we are not preferring this because in that case, we have to find these angles. This angle. Now, but if you will see carefully in this, so now we know this 16. And then we know this reaction 12 kilonewton. So we have only one force which is in vertical direction, and that is U1, U2. Now actually we have this angle. So now we have, if we will go through this, we have this angle 30 degrees. But to consider component, we are required this angle. So we have like this. Now we have below, then we have this. So now we have this as 1.15. This is 2 meter. Now if we will go tan of 30, then we have tan of theta. I am considering this angle. So now if we will go theta, then we have tan of theta equal to. So 1.15 divided by 2. And if you calculate this value, 1.15 by 2, then we have tan inverse 1.15 divided by 2. So this angle we will get as again 30 degrees. So we have this as 30 degrees. By observation also you can make it. So we have this as 30 degrees. And therefore we will get component F U1 U2, that is cos 30. And vertical we have F U1 U2 sin 30. Now if we will take moment about U not 0, then we have moment due to cos 30. So clockwise F U1 U2 cos 30 into 1.15 due to sin 30, that is also clockwise, into 2, and due to 4 also clockwise, plus 4 into 2 equal to 0. And now if we will consider this, then we have this as 1.15 cos 30 plus 2 sin 30, and that is equal to minus 8. And if you will solve this part, you will get value equal to 2, and therefore we will get F U1 U2 is equal to minus 8 upon 2 minus 4 kilonewton. Means we have F1 U1 U2. Sorry, F U1 L2 we have. U1 L2 we have. U1 L2. So we have F U1 L2 we have to find. So we have this as U1 L2. And then U1 L2 we have 4 kilonewton compression. Now in this you can use summation Fy equal to 0 or I am saying. And then we have 12 minus 2 minus 4, then minus 16 sin 30, and then minus F U1 L2 sin 30 equal to 0. Now you can see this becomes 8. So we have 8, 4, 12, 2, 14, and this 12. So we will have this as minus 2 on this side. So if we will, it will go on this side. it becomes plus 2. And therefore we will get FU1L2 minus 2 upon sine 30, and this becomes minus. You can check it. You can take moment, you can take y0, you can take fx0. Only you have to check what I can use and which will use me value easily. And then you have to round up this. You have to show correct direction. Likewise, we have to find forces in the members. So now we will stop here only. Remaining part we will see in the next lecture. So thank you.